Page 7 is very short. It's only 2 correlation causation problems, so this video should be very short. It says determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, describe the meaning in the situation. So here we have a scatter plot, average cycling speed. The y-axis is marked off in miles per hour, going up by 2s, and the x-axis is marked off in minutes. It is increasing by 5. None of that really matters. What matters is if you look at that data, you need to decide whether that data is generally increasing, decreasing, or if there is just no obvious pattern to that data. And I think we can all agree that for the most part, those 5 points are very clearly going down as we move from left to right. They are very clearly decreasing. Now, I drew a rough line of fit in there. Remember that the line of fit tells us whether this correlation is negative or positive. And this is probably not the correct line of fit. It's just a rough estimate. But notice that when I draw that line in there, which does a decent job of recognizing that these points are decreasing over time, that line has a negative slope, right? Downhill. So if it has a negative slope, then this graph has a negative correlation. Now, we're then asked to explain the meaning of the situation. Only let's look at the answers. Oh my God, only one of them is negative. That must be the right answer. But what this is saying is that as time passes, as time is increasing, speed is actually decreasing. So as we move from left to right, and we're moving up in time, that speed is going down. So our answer would be B, negative. As time passes, speed decreases. Let's do another one. Number 37 here, I don't know about you, but it kind of looks to me like somebody randomly threw up on that scatter plot. There is no obvious correlation. So this one should be even faster. When we look at this, we can't really draw in a line of fit. Because look at this. I will draw 2 different lines in here. You decide which one of these better represents the data. So here's one, and here's another. I would argue that those 2 lines are about equally good at describing this data. The problem is one of them is positive and the other one's negative. So this would be one of those situations where, and I'm just going to remove those lines because there is not a good line of fit here. This is a situation where there is no obvious line of fit because the data is too random, too spread out. So this would be an example of no correlation. That does it for page 7.